Hello and welcome to our virtual Lunch and Learn. Today we're talking about Fluke ii900 Sonic Industrial Imager. My name is Rachel Green. I'm the Digital Communications Specialist here at McNaughton-McKay Electric Company. And presenting for us today is Gino Porter, Automation Specialist Power Control out of our Charleston, South Carolina location. Out in the comments section, ready to answer your questions today is Bill Dunlap, Territory Sales Manager for Fluke. We'll also have a Q&A portion at the end for Gino to answer your questions in more depth. We'll be getting started shortly, but we'd like to allow a few minutes for attendees to join us. As you come in, let us know where you're tuning in from in the comments section. You can view recordings of previous virtual Lunch and Learns on the YouTube channel under Virtual Lunch and Learn playlist, and we cover a new topic each Wednesday at noon, so be sure to join us on your lunch break. For anyone just joining, welcome to our virtual Lunch and Learn. We'll be looking for questions as you have them in the comments, while our presenter, Gino Porter, gives us an overview of the hardware, basic user interface, and utility cost-saving benefits of the Fluke ii900 Sonic Industrial Imager. Hi, Jody. Thanks for joining us today. Our Fluke specialist, Bill Dunlap, is ready to respond to your questions in the comments as we go along. We'll also have a Q&A segment at the end of Gino's presentation. If you'd like to reach out to us afterward, or if you have further questions for Gino, you can always send us an email at macandmaclive@macandmac.com. Just be sure to let us know which session you attended so that we can get your questions to the right person. We'll have that email address on the screen for you at the end of the presentation as well. And it looks like we have a number of attendees with us now, Gino, so I'm going to pass it over to you.
All right. Good morning, good afternoon, and good evening to everyone across the globe joining us today. For those of you that are joining us in the United States, happy Veterans Day to those who have served and those who are serving today. We appreciate your service here at Mac and Mac, and I personally appreciate that. Today we're going to be going over the Fluke ii900 Sonic Industrial Imager, and as we go through it, if everybody could just leave a comment letting us know where you're tuning in from, let us know what city and the company, that would be awesome. So without further ado, let's begin. So what is the Fluke ii900? We're going to start off with basically going over the basic concepts of acoustic imaging. After that, we'll walk into some applications with a brief video demo. And then we'll talk about some practical considerations for use of this technology. And then at the end, we'll go over the LeakQ feature, which is used for estimating cost savings. Because if it doesn't save you dollars, it doesn't make sense. And then at the end, we'll answer any remaining questions if there are any. Again, we'll have Bill Dunlap, Territory Sales Manager for Fluke, in the comments if you have any questions, so don't be shy. So what is sonic imaging? I'm a big fan of this picture that you see on the left of the screen. If you ever worked in industry before, you probably may have not used a tool for monitoring the air leaks, but you probably use a tool that's called a thermal imager, and that's what I really like to compare the feel and use of this device. So how does the thermal imager work? Basically, you take a device and you point it at something that has a heat source. So, for example, let's say you are going out to measure for hot spots on a transformer. You're looking at the bushings or where the connections, where you make the cables at. If one of those cables are a lot hotter than the other, that means you probably have a problem there. And on your display for your Fluke, on your Fluke thermal imager, it will show a big red spot, giving you a simple indication that, hey, something's wrong here. We have something, in that case, it'll be heat that's hotter than the other devices, that's hotter than the other ambient temperature. If you worked with one of those before, you can pick up a Fluke ii900 and start measuring air leaks pretty quickly. So the Fluke ii900 is a sonic imager. It is using sound to pick up air leaks or gas leaks or vacuum leaks from a device. So let's step into that. So what technology is the Fluke ii900 using to get this meaningful data to capture air leaks? Was using all the Fluke SoundSight, where it's a technique where it takes a visual image and it places a sound map on there. So what does that basically mean? It has a camera, just like you'll have on your phone, and it gives you in real time, a live picture or a live video of what you're seeing. On top of that live video, on top of that live image, it's going to overlay the information that is picking up from the microphones, and it's going to point out where that leak is. So if you look at the picture to the right, you'll see it's just a standard screenshot or a standard image. So you can have some type of reference of what you're looking at. And on top of that, it's giving you some, like a gradient of different colors. Whereas you imagine red is going to be, hey, there's a problem. This is where the source is. And as that gradient changes, the severity, the amplitude of that leak falls off. So that's basically what is using here. So if you use a thermal imager, the image looks very similar to this, but instead of using a device to measure heat, we're using devices to measure sound. That sound is called a microphone. And the device is called a microphone. So just to recap what we just said, how does it work? So on the back of your ii900, you have basically this gray square that's going to encompass a visible light camera. Again, just what you'll see on the back of your modern day cell phone or tablet. And then surrounding that, you have 64 microphones to detect sound. These microphones are what I like to call smart microphones because they have some diagnostics that basically tell you when they're about to fail or when they have failed. So you don't have to guess whether your ii900 is in good shape or not. So why does it have 64 microphones to detect sounds? That might sound a little excessive. Well, it's important that you have these number of microphones because basically the technology is using triangulation to build the sound map. So what does that mean? It's taking a lot of samples and using some high-level trigonometry, some high-level math that's above my pay grade, but the engineers and designers found out the way. If we have 64 microphones and we use this method, we can pinpoint the location of the leaks, of the air leaks, and overlay that onto the image or onto the video in real time, which is pretty cool. And so on top of the location of where the image is, which we're calling sound map, you're able to determine the frequency of what type of sound is being made or what type of leak it is, and also the amplitude. So again, talking about that image, when we flip the ii900 around to the other side, you're going to have the 7-inch widescreen that's going to produce this information. What information are you seeing? Again, you're getting your real-time video, your real-time image, which you can see this is an image that was taken in a pretty dark area. Most of our factory floors are not going to be well lit in most cases. So this is showing us that, hey, it's a pretty decent camera. It's pretty good quality. On the bottom, it's going to give you a timestamp and a date stamp so you can know at what time, what hour the event happened, and also gives you a battery indication. But more importantly, that picture, which you see in the middle, what are you seeing? you're seeing basically an array, a gradient of different colors. Again, red is going to indicate where the peak of that source is. And how can we tell what these other colors mean? So to the right, you're going to see an oval basically giving you the range of the scaling of what those colors mean. And on top of that oval, you'll see that it says 56 dB. And on the bottom, near the dark blue color, it'll say 53 dB. dB stands for decibels. Decibels are used to measure the amplitude of a sound. Two characteristics that you need to understand or know when we're talking about sound. It's going to be your amplitude and your frequency. So to the right, it's going to give you your frequency band, which scales from anywhere between 2 kilohertz all the way up to 55 kilohertz. And as you can see, on that frequency square, it looks like a rectangle, almost looks kind of like a ladder. You're able to set up a band of the minimum frequency and the maximum frequency that you're interested in capturing. However, with the Fluke SoundSight technology, it is pretty smart, pretty intuitive enough where it's able to filter out the ambient noise and lock on to where 9 times out of 10 where that leak is at. So that makes it very intuitive for someone who's not an expert in air leak detection to get the head wrapped around the concept. So what are some target applications for testing air leaks or gas leaks? One might be, hey, I'm interested in looking at compressed air leaks. That's the ii900 application. Gas leaks, vacuum leaks, steam leaks. If you have these inside your plants, this is an ideal tool for you to use for your preventative maintenance system. A lot of customers, traditionally will probably have to hire out a company that is specialized in studying air leaks, where you've probably seen these guys around. They have the headsets on with this tube and are walking around pointing, trying to find where the air leaks are. And that takes quite amount of skill, quite amount of training. And if you're outsourcing that, that's going to cost your company quite a bit of dollars. And so you're looking at the ii900, you can do this in-house. You're able to pick this up and do it intuitively yourself and get some meaningful data. And it's not going to require as much training and skill, again, to get much data. And also, it's going to reduce the amount of time for you to find these compressed gas, vacuum, and steam leaks. So we're going to take a pause and look at this quick demo video. Excuse me as I have to get my settings in line in order for you to be able to listen to the audio. Bear with me. Here we go.
Gino, are you there?
Yeah,
Can you pause for us?
Sure.
We're not able to hear it. I think maybe if we select your computer audio.
Yeah, 1 second.
Okay.
Optimize video. There we go.
All right.
Let's try it again. Any luck here?
Not quite. No, we're not able to hear it.
Okay, no worries. I'll just speak over for it for about a minute.
And if you'd like, you can share that link with me and I'll drop it in the comments section.
Sure, 1 second.
Okay. Sorry, folks, we did test this before and it was working great. So sorry about this, but we'll get that link for you in the comment section.
I'm going to lean on Bill Dunlap. I'm pretty sure he has the link for this video. It's based off of YouTube.
Sure thing.
And I'm going to press on. Okay, guys. Sorry about that.
Sounds good. Thanks, Gino.
No worries. All right, so how do these sound waves work? Sound is produced when something vibrates. So for example, if you have a guitar, all right, you pluck that string begins to vibrate, assuming it has enough tension on it. And then that vibration thus puts a force, moves onto another medium. That medium that you and I are interested in, it's going to be air. So Fluke SoundSight technology uses sound created by leaks to identify the source. So again, it's the Fluke SoundSight technology uses those typical frequencies that you're going to hear from gas leaks, from air leaks, vacuum leaks, and it's going to be able to pick up that frequency and be able to pinpoint and give you a nice clean image. Almost kind of like how a camera will work, right? A digital camera. If you're an expert, right? If you got a one of those fancy cameras where you can adjust the ISO, the shutter speed, your aperture. If you have that type of skill, then sure, that's great. But for your amateur photographer, you just want to be able to point your camera at something and all those settings get adjusted in the back end where you get your quality image. That's a good parallel for the Fluke SoundSight technology. The basics of acoustics. Start off with Amplitude. On the left, we have a pretty cute graphic where you have a bird with a small amplitude and a bird with a louder amplitude. You can see these birds have the same frequency, but as one bird is a little bit louder than the other, probably because it's hungry and hasn't had a worm in a while, that sound signal gets converted into electrical signal, and you graph that wave goes up and down. But again, you can see the frequency is the same. The amount of times it makes a cycle, the amount of times it goes up and down, it's the same. So it's almost like amplitude modulation if you're in old school radio or current radio, if you're into talk shows. On the right, it's going to give us a range of decibels of basically get some relative numbers on how we can equate decibels on a human hearing factor. So at around 0 dB, that's about the hearing threshold of where the ear can pick up the sound and your brain start putting some data to figure out where that sound's coming from, what type of sound it may be. And you start getting around the 140 dB or 140 decibel range, that starts becoming pretty harmful towards the ear and the eardrum. It can be pretty painful, if not catastrophic, towards the ear system. Second part is going to be frequency. All right, the more spread out that wave is, all right, like a slinky, the more you spread that out, the less that frequency is. The more compressed that wave is, that means the higher that frequency is. So the less compressed, the more expanded that wave is, the slower that frequency is, you're going to have basically a lower sound, kind of like my voice. But higher that frequency is, it's going to be around the ranges of bats and dolphins, and that's going to be the frequency they kind of communicate on. So on different devices, different living beings, different, et cetera, it's going to have different ranges of where you're going to find those frequencies at. So just to put this in summary, in terms of the Acoustics 101, sound is going to be made up of lots of different frequencies. Compressed air will also have a mixture of frequencies, right? And not all leaks are going to be the same frequency. So why is this relevant? This is why we need to be able to select the frequency band in the instrument, because different leaks are going to have different type of frequencies. If we're interested in finding a particular type of leak, we want to be able to have that control of filtering out that particular frequency. So practical considerations for use. It's going to be pretty handy if you're going to be the person using these instruments inside the field. So good practical consideration for use is going to be reflection. What is reflection? Let's say I have some air coming out of a primary source, right? It's coming out of the connection of where I got a valve, or the connections of where my compressor system's located. If that air is coming out, and let's say it starts bouncing off the ground, right, which is very practical, your Sonic ii900 is going to pick that up, right, because it's picking up that sound, it's picking up that leak. So how can you tell whether something's a reflection or if it is the source? Great question. This is what this pictorial graph is showing us. So picture A is showing an image of someone holding an ii900 and pointing it towards the ground. So the technician is going to have enough experience to be able to scratch their head and say, hey, is there air coming from the ground, or is this a reflection? But if you don't know, here's a trick. Move your location, right? Change your position. And if that spot on your ii900 moves on the screen, then that means it's not the true source. That means it's a reflection. So what you need to do is continue to move. As you move into picture C, right, the reflection moves. You move into picture D, that reflection moves, that source moves. Finally get to picture E. Things are starting to make a little bit more sense now. This is a connection of where the hose connects to another fitting, which is probably very ideal, something very, probably something that is pretty often of where you have some type of leak at. And you can confirm that by, again, picture F, moving your location, and that source stays there in both pictures E and F. So you can determine, hey, that's my leak. Let me record my video. Let me record my image, make my notes, and send that on my way. So what are going to be some of the buttons on the screen? So the soft buttons that are available, again, we touched on this before. Let's look at your frequency band. On the frequency on the right side of your screen, you're able to, again, adjust where that frequency band's at. You can also expand or contract how much frequency you want to be able to put in. You can select what type of band you'll like to have. If you look towards the left, you can change the mode from video mode or image mode. You can check your memory. You can check the settings on your acoustics. You can change your palette, which basically means what type of colors you would like to see for your amplitudes. And you can change your markers. That marker is basically going to be where your pointer's at, towards the middle, and your setting. So instrument operation buttons. So fortunately, Fluke decided to follow the KISS theory, keep it simple, Steve, and only have 2 buttons on your ii900. Those 2 buttons being your on-off switch and your save button. The rest of your buttons are going to be soft buttons that we, again, just touched on 2 slides ago, and this gives you a little bit more detail. These soft buttons can be toggled on and off. Your general info, your center readings, and your general info and your center readings can be toggled on or off based off of your preference, whether if you want that data to be on while you're doing your testing or not. And then you can, again, dive a little bit deeper, but for this presentation, we're going to keep it high level on what's available. So like we said before in the presentation, if you're not saving dollars, it doesn't make sense, right? So Fluke has made it very simple for you to target the leaks that are causing you the most amount of dollars, and also to be able to create some reports. So if you're in business for finding leaks and showing the cost savings, showing the ROI for a customer or your reliability manager or your power engineer, they're giving you the tools to be able to do that and create those reports. How can you estimate some of these costs, right? So here's a US DOE example. If you look at the cost savings formula, if you want to go back to your high school or college algebra class, go forward, but we'll keep it simple. If you look at this first bullet point on your left, it's basically saying that if you have a leak with a diameter of 1/32 inches, and you have a quantity of 100 of those, that can cost you up to about $5,765. I believe that's per year. If the hole's a little bit bigger, right, 1/16 inches, 116 inch of a leak, and that occurs 50 times, it will, if you have 50 of those leaks, right, and your miles and miles of air hose, that costs you $11,000. You have a 1/4 inch leaks, and you have quantity 10 of those, that can cost you up to over $39,000. So you can see this number adds up pretty quickly. And in this example, total savings is $57,069, 57069. Sorry, a little off today, but it can save you a little over $57,000. $57,069. There we go. So when you get this device, make it a good challenge on how many leaks you can find with the i900, because that can start putting a lot of dollars back into your company's budget. And if you save enough, you'll probably get that employee of the month parking spot that we all crave for. I know I do. So there's some different modes that are on the Fluke ii900 camera on the screen. And so there's the image mode, where you're just taking some photos, and then where you're just taking still images. And then there's also the LeakQ mode, which kind of goes back into your prioritization. So what's the LeakQ mode? The LeakQ mode, basically, if you see how there's a circle on the screen to the right, on the picture on the right. If you put a leak into the center of that circle, it's going to give you some data, and one of those data points is going to give you a LeakQ scale. In this case, it's a 4.7, right? Just a relative LeakQ scaling. But the higher that number is, the more dollars that leak is costing your company. So if you just want to have someone that dedicated to finding these leaks and just prioritizing to which leaks you need to address first, or which ones you're going to address during the outage, you can just have them focus on the highest numbers on the LeakQ scale. Focus on everything that's a 4 and above, or 3 and above, and that way you can start saving the most amount of cost by eliminating your biggest waste. So another tool that Fluke is offering on their website, they have estimating cost report. I believe it's in some software you can download as well on your machine, where you can input or import the data in from your testing. You can import a nice pretty picture into your report and make notes that we can start managing it over your preventive maintenance program. You can select what type of air type, you can select what type of gas you're monitoring. You can select the type of pressure that the source is putting out. You can input the amount of dollars that it's costing you. If you have this data, you can ask your power engineer or your utility, what's the cost per kilowatt hour for your from your electric company. So the more accurate data you put in, the more data you put in, the more accurate the number you can receive for your ROI or rate of return. So here's some general specs. Again, there's 64 microphones on the back of a device on the sonic imager. The frequency range varies from 2 kilohertz all the way up to 52 kilohertz. Might go a little bit higher, but stick with the specs here. The operation distance, this is important, and it's good from 0.5 meter to 50 meters, and this depends on the ambient conditions. So based off it's going to be based off the available amount of light, the amount of ambient noise that's in the facility. It's going to be, and some other factors, right? Based on the ambient conditions, you can get up to 0.5 meter, up to 50 meters. From 0.5 meter to 50 meters worth of operation distance, which is pretty significant. One thing I like to highlight is that these come with rechargeable lithium-ion batteries, and it also comes with a spare. So each battery can get you 6 hours worth of battery life. So with these two batteries combined, you get 12 hours of battery life, and it comes with a dual charger. So you can charge both of these batteries after use, and it only takes you 3 hours to charge up the battery. So you can roll continuously for a very, very long time up until get the maximum use out of that battery's life cycle. It has a significant amount of memory on this device. You can store up to 999 picture files and up to 20 video files. You can save videos up to 30 seconds. You can pull this data into your computers or to your laptops. It uses a USB-C connection. And again, on the bottom, it's highlighted that these microphones have some self-diagnostic features where you're able to identify which microphones or how many microphones are faulty and when it's time for service. Here are some sample images that you can pull that are from real applications. On the left, you'll see some examples of vacuum leaks. And on the right, you'll see some examples of air leaks. This is real world applications. On the right, some pretty good examples of some reflection going on in the facility. So it's pretty intuitive to be able to tell, hey, the source of my leak is right where the red is happening at, and where these blue spots bouncing off the floor is probably going to be some indication of reflection going on, or air possibly coming from down below. So again, that wraps up the presentation on the Fluke ii900 Sonic Industrial Imager. I appreciate everybody joining us on our weekly Mac and Mac YouTube Lunch and Learns. And if you have any questions, feel free to comment in, and I'll pass the ball back over to Rachel.
Thank you, Gino. What a fascinating and useful tool. It does not look like we have any live questions at the moment, but as always, we'll give a few minutes here at the end in case you have some follow-up questions for Gino. As we wait, I'd like to remind you that we've added that link to that video from earlier in Gino's presentation into the comment section on the right. And if you're watching this as a recording, that video link will also be in the description below. I want to remind you always you could reach out to us at that email address on your screen, macandmaclive@macandmac.com, with any questions for Gino. Just let us know the name of this session so that we get it to the right person. And with that, I want to thank you again, Gino, for a wonderful presentation today. Thank you, Bill, for being our resource out in the comments section. And thank you to all of our live viewers today, joining us all the way from Argentina even. Thank you for your time. We love to see you out there watching us live. Remember to subscribe to the McNaughton-McKay YouTube channel for more industry content, and we look forward to seeing you live again next week. Thank you, everyone. Have a great day.